All right, folks, let's talk about how to sketch the curve y equals the sine of x. So we're going to do this old school, the way you first learned how to graph, and that's to make a table. So if I go to my unit circle and I look at the y coordinates for all of these terminals, I should be able to fill in this table, okay? So if you notice, the table is actually asking for kind of the quadrant terminals. So we're going to be doing a lot of 0, 1, 0, -1, 0, etc. So I have the unit circle memorized. At 0, the sine or the y coordinate is 0, and then it's 1, and then it's back to 0, and then it's -1, and then it's back to 0. Now if I go backwards, right, backwards on the unit circle, so if I go down to -pi/2, I'm actually at -1, and then I come back up to 0, and then I go to 1, and then I'm back at 0. Now the problem with this table is it only has 0s, 1s, and -1s. So when I go down here and I sketch this, right, it says plot the points, I need to make sure that I understand there's going to be a lot more stuff going on, and this is actually going to make kind of a wave or a curve. So let's go ahead and graph all these dots. So we're at -2 pi, we're at 0. -3 pi/2, we're at +1, and then 0, and then -1, and then 0, and then 1, 0, -1, 0. I'm missing quite a few coordinates. I'm missing all of those terminals, 30, 60, 45, 135, 150, 210, 225, 300, 350. So there's a lot of numbers in here. And so if you go to the unit circle, what's nice about this is if you look at these y coordinates, you can see that it makes a wave in the upper half. So 1/2 is 0.5, 0.7, 0.86, 1. It's kind of like leveling off, and then it goes down the hill. So this little arc here is really a good representation of the behavior of the graph. So when I sketch this, okay, and I'll just start here and go this way, it's actually going to make a symmetrical wave like this. And if I go back the other way, same thing, a little symmetrical wave. So this is a pretty good depiction of what the sine curve looks like. Now, that's in radians, right? So these are all radian angles. So if you're plugging in these into your calculator, you got to make sure you're in the radian mode. Let's answer some follow-up questions. Why does the graph stop at 2 pi on the x-axis? Well, because that is one complete revolution. So that's all the way around. We could keep going. I mean, a lot of times we teach to go to 4 pi, 6 pi, 8 pi, 10 pi. We're going to stop after one complete revolution. The domain of the function is what values can go in. You can take the sine of anything. So this is all real numbers. And that is because you can take the sine of any radian measure. The outputs are the range, and you can see that this graph kind of has a peak wave at 1 and a bottom out at -1. So it's inclusive of -1 and every number up to 1. So this includes every number between -1 and 1. You might write it as this. The last question says, over what period or interval does the x graph repeat? Well, you can see, if I just take a highlighter here or a different color, this orange wave, okay, kind of repeats in loops, almost like an audio track. It loops right here. And that's every 2 pi. So you can see right here that this is about 2 pi, so 6.28 radians and another 6.28 radians. I could keep going, and every 2 pi you would see a wave repeat like this. Okay, now we're going with cosine. Now, cosine is very, very similar. In fact, you're going to realize that it's almost the same thing. And that is because the behavior of the x-coordinates is very similar to the behavior of the y-coordinates. So if you look, it goes 1/2, root 2 over 2, root 3 over 2. Well, look at the x-coordinates. It's root 3 over 2, root 2 over 2, 1/2. So it's kind of like an offset of what's happening with the pattern of the y's. So when I fill in this table now, okay, now I'm going with cosine. So the cosine of 0 is 1, and then it's 0. These are x-coordinates, right? X-coordinates on the unit circle. This is -1, 0, and back to 1. If I go backwards, okay, this is 0, this is -1, this is 0, and back to 1. So if you look at these coordinates, you can see that it's just an offset. It's literally taking this entire thing and shoving it this way 90 degrees. So watch. 1, 0, -1, 0, 1, 0, -1, 0, 1. You can see that it's the same type of behavior. Now again, what we're missing is all those radian values between, right? So pi over 6, pi over 4, pi over 3, etc. And it's going to behave the exact same way that the sine curve does. It's just that it's offset. So here you go. Why does it stop at 2 pi? Again, that's one complete revolution. We don't have to stop there. We could keep going because this is going to loop and loop and loop. Domain is again all real numbers. And the range again is a bottom out at -1 and a top out at 1. Again, you might write it like this. The period is still 2 pi, and I'm going to show you why. On cosine, watch what happens from -2 pi to 0. Look at that curve. It makes kind of what we call a U. You see the U. Well, if I take the blue marker, you'll see that that U will show up again right there. And that's 2 pi in length. This is 2 pi in length. Check it out. -2 pi to 0 is 2 pi. 0 to 2 pi is 2 pi. So every 6.28 radians, we have a loop. Let's get some transformations. So the first thing you need to know is that this number right here in front of sine, that number is what we call the A value. This value will control the amplitude, which is the height of the waves. Okay? Or you could call it the radius of the unit circle. Okay? The amplitude is how high up the sine wave happens. So, every one of these problems, here's what's going to happen. I need to look at the wave height, and I need to know that my sine curve is going to do this. And normally, when I draw this little midline, these heights are 1 and -1. But that 2 is going to make it twice as tall. So let's go in here and sketch. Instead of 0, 1, 0, it's 0, 2, 0, -2, 0. I'm just going to take all the values in my table that I made at the beginning and double them. So this one would be -2, 0, +2, 0. And so when I graph this, my waves are twice as tall as they were at the beginning of the worksheet. This one, they're 3 times as tall, but they're upside down. So what's going to happen is this wave is going to invert, and what's up is down, and what's down is up. So this 3 is going to make the amplitude 3, but that negative is going to flip the waves upside down. So normally we would go 0, 3, because it's negative. I actually go 0, -3. 0, +3, 0. I'm going to sketch this one right away. This is -3 sine from 0 to 2 pi. Now let's go the other way. This is normally down here, but now it's up here. 0, -3, 0. This one has what we call a midline shift. The midline is the center of the waves. You can see here that the x-axis is the midline for this one and this one. When we have a midline shift, the best thing to do is to go ahead and put a dotted line in there to represent the center of the waves. The next thing I like to do is look at the amplitude. The amplitude is 3, and so I like to take a lighter pen and set the height lines up there. I put that blue line 3 away from the midline because this is the height of the waves. This is the middle of the waves. So I want to put another blue line 3 boxes away from the gray line. Starts to look like old school penmanship paper. When you'd learn cursive, right? You would lowercase, uppercase, lowercase, uppercase. So this model is going to help us here. Okay? So first dot is usually at the origin. The origin is now here. Hold on. Second dot would go up and be the top of the wave. The third dot would be here. The fourth dot would be here. And the fifth dot would be here. And so here is the graph of 3 sine of x plus 1 from 0 to 2 pi. It's behaving just like this one, but it's shifted up 1. And again, flipped, right? Okay, now we go backwards. So here would be down, and then back at the midline, and then top, and then back at the midline. Here's your graph. This one, we have a midline shift of -2, so I'm going to come in here and make a dotted line. That's my midline shift. And then I have a height of -1. So my blue line is just going to be 1 box down and 1 box up. And my waves have to fit in this region. So here we go. 0. Remember, I normally go up, but because that's negative, I go down, back to 0, up, back to 0. Here is negative sine minus 2 from 0 to 2 pi. Let's go the other way. Here, 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 here. You can see that because that has a negative, the behavior is down, up, down, up, down, just like this one. Down, up, down, up, down. Let's go to cosine. I have a height difference of 4, so my amplitude is 4. So I'm not going to change the midline, but just for the fun of it, I'm going to put my blue line in at 4, my other blue line in at 4. I have to stay inside the paper. Okay, so normally it would be, we start at 1, right? So normally we start at 1, which should be here. I'm going to start at 4, and then go down, and then go all the way down, and back up in here. Here's your 4 cosine. Let's go back this way. 0, down, 0, up. Okay. -2 cosine. I do not have a midline shift, so I'm just going to put my wave lines in here. And this time, instead of starting here, I'm actually down here. And back to 0, and up, back to 0, and down. And then I go back this way. 0, and up, back to 0 and down. Let's midline shift. +2. Here's my middle. My waves are 2 high, so 2 boxes from the middle, 2 boxes from the middle. 2 cosine +2. So I start up and here and down and 0 and up. Zero and down and 0 and up. There you go. Last but not least, midline shift of -1, so here it is. And I want my heights to be 3. Make sure gray is in the middle. Now -3 means I wouldn't start on the blue line up here, I'd actually start down here. So there, 0, up, 0, down, and back, 0, up, 0, down. There you have it. The reflection question says, if sine was rewritten to 4, sine of x minus 3, describe how the original graph would change. Well, if it was the sine of x, it would look like this. And then I'd go backwards. Right? But because it's not the sine of x, because it has a -3, I would first see the center of the waves move all the way down to -3. And then I would actually have the wave height show 4. So I would have to go down this -7 and put my blue line in there. And then I would have to go up 1, 2, 3 to 1, put my blue line in there, and now my waves fit that realm. So they go up, come down, and come back. And then going backwards is the same thing. So you can see the shift here. How would you describe that with words? You would say the midline would be down 3, and the height of the waves would change to 4.